Hello. In today's lesson, we'll be reading math word problems. These word problems will be multi-step word problems. This simply means that we'll be asked to complete two or more math operations in the same problem in order to find the correct answer. We practice word problems in math because they help us apply the basics of what we learn in math to new situations. This can help us see math in our real world and apply it to situations we come across in life. After all, what would be the point of learning all this math in class if we never take it outside of the classroom? Alright, let's get into it. Yara goes to the mall to buy some shirts. She buys 34 shirts for $28 each. She saves $79 with coupons. How much money does she spend? Now let's think. What are we doing with numbers? And what is the question actually asking us? We're going to take the 34 shirts and visualize or see $28 on each of those price tags. We are then asked to find how much she spent, so we need to add all 34 of those price tags up. Instead of taking the time to add that many things up, we know that when we have to add the same number up over and over and over, another math operation was invented a long time ago to help us with these kind of problems. Multiplication. We can multiply 34 times 28 to get 952. So for these problems today, I'm just going to use a calculator to speed things up. I want you to start thinking about how to do these math problems as we read them and understand them and comprehend these math problems. And I don't want us to spend too much time getting caught up in the actual math of it. This lesson is focused on understanding what we want to do with the word problem and understand what kind of math we're going to use. Alright, so that's why I'm using a calculator. Alright, so that's the first thing. But it also says she saved $79 with coupons. When you're spending money and you have a coupon, you wouldn't want that store clerk to forget about your coupon. Alright, in this word problem, we can't forget about the second chunk, because it's very important. If we spend that much money on t-shirts, we at least want to save a little bit if we have the coupon. So in the second step, we're going to take 952 and we're going to subtract $79, because that's how much you save with coupons. What happens with math in real life when you have a coupon, it's that thing that you're saving is taken away from your total. So if we take 952 minus the $79 coupon, then Yara ends up only spending $873 on shirts, which is still a lot of money for some shirts. Let's continue with the second problem and determine how many steps it will take to do it. That last problem with Yara was a two-step problem because we had to do two operations of math to solve for the answer. Let's try a new one. There were 88 new car riders each day for 15 days in a row. On the 16th day, there were only 34 new car riders. How many new car riders were there in all? Remember, with any math problem, we need to think about what the question's actually asking us to do. In this example, they're telling us to find the in all, to add it all up to find the total of how many new car riders there were in all the days, all 16 days added. Now, if we rushed here, we can make a silly mistake. We could just take the three numbers we see the question says in all, we just add up 88, 15, and 34. But that's not actually what we do. If we read carefully, they're saying that's 88 new car riders for 15 days in a row. So that'd be 88, 88, 88, 88, over and again until we hit the 15th day. And then we add on a 34 new car riders on the 16th day. Alright, some students I've even seen with these type of problems, they have four numbers in the problem. 88, 15, 16, and 34, and they even throw that 16th day in there as a number to add up, because they're just not reading and thinking through carefully what the story is asking. So we need to break this into two steps. The first step that makes the most sense to me would be taking 88 and saying that has to happen 15 times. Instead of adding 88 stacked 15 times, that will take a long time. We know that multiplication was invented for repeated addition. So we can say 88 times 15, alright, will give us 1,320. Alright, now we're going to look at the next step. The next thing, that covers days 1 through 15. Now we need to know the 16th day added to that. So if we already have 1,320 new car riders, we need to add the 16th day, which is the only missing piece left. Alright, if we add 34 to what we already had, then now we have 1,354 new car riders. The last huge thing when we're solving for math word problems is we need to skim over this information one last time or twice, and we also need to check our math. Now that I have a calculator, you still can check to make sure your numbers you put in are the right numbers, but especially when you don't have a calculator, you need to check your math. We also need to make sure you're reading your word problem through once or twice after you solve to make sure what you just did, math-wise, makes sense with what they actually asked you to do. Let's try the third problem and decide how many steps they're asking us to do. There are 3 shops in the store 1 has 38 candy bars, store 2 has 78 candy bars, and store 3 has 39 candy bars. If they all get a shipment of 85 bars, what will be the total of the 3 stores' candy bars? Alright, there's a lot going on here. First, what is the question asking us to do? What do we need to find? What's the goal here? Alright, we need to find a total, and it says what will be, which means the future. What will be the 3 stores' candy bars after that shipment comes? So first we need to find out the total of all the stores' candy bars, because they're asking us to find the total. But then we also need to find how many the shipment will be once that's all put together, and then we need to find the total of those 2 things. So to me that sounds like 3 parts. Adding the store's total candy bars, all 3 stores' totals, alright, finding the total what the shipment will be of all 3 stores, and then putting what they have currently together with what they're going to have to find what they will have in the future. So we're going to do 3 steps in this problem, which is not totally uncommon for 4th grade math. So let's break it down by those 3 steps. Step 1, we need to see, okay, there are 3 stores. We need to find the total candy bars, so let's add those 3 up, which would be 155 candy bars. Now we need to move to step 2, which says all 3 get 85 bars as their next shipment. So that'd be 85 3 times. We could say 85 plus 85 plus 85, but again, we're thinking about repeated addition being multiplying here. So we could say 85 times 3 for step 2, which gives us 255 candy bars. Now if you remember earlier I said, now for the 3rd step we need to take what they already have total and what they're going to have after their shipment and combine them. If we're taking 2 numbers and putting them together to find the total, then we'll be adding to find our final answer. Alright, so if we add those up, 255 plus 155 would end up with 410 candy bars after all 3 stores get their shipment for their total. Alright, and now I feel like I've answered the question because the question was asking me the store's total candy bars after the shipment comes. And once again, just to reinforce the point here, once we're done with the problem, we're not totally done. We want to skim through it once or twice to make sure what we did, math-wise, lines up with what they actually asked us to do. Because if we don't do that, we can do the best math ever and get all of our math right, but if we didn't do what they asked us to do, the problem's still wrong. Right? And we don't want to do all that work for nothing. Alright, this is a big problem because there's a lot going on here, and there are a lot of tricky little parts. Alright, so let's break it down and decide how many steps this will be with math operation. There are 67 hippos in the river. They each eat 54 veggies a day. There will be 2 hippos that will not be in the river on Friday. How many veggies will be eaten by hippos in the river on Friday? The question has a few little tricks in it because it says in the river on Friday. So we need to consider those parts and either add or subtract based on what we need to look at there. Alright, so let's break it down. First, the question. What is the question asking us to do or solve? We want to know how many veggies we're eating. We don't want to know the total number of hippos of anything. We're going to know how many veggies will be eaten by the hippos in the river on Friday. So we need to find the total of veggies. There are 54 veggies a day, but that's multiplied by 67 hippos, because it didn't say they eat 54 as a team, they eat 54 veggies each. Alright? In reality, that's probably a low number, because hippos can really eat. So 54, 67 times repeated addition. We don't have to say 54, 54, 54 a bunch of times. We can multiply. 67 times 54 will give us 3,618 veggies. All right, but we're not done yet. That's just step one. But then it says 2 of those hippos will not be in the river on Friday. They'll be somewhere else. So we need to take their veggies out of that because the question is asking us how many will be eaten in the river on Friday. And those 2 hippos won't be eating in the river. All right? So now we need to say how many will be missing. Well, that's 2 hippos times each of their 54s, right? He eats 54, she eats 54. Both of those 54s are out. So you could say 54 times 2 would be 108. That will save us time instead of adding 54 and 54, even though that's pretty quick too. All right, so that's step 2. Now, we need to say, let's take that out of the total number of veggies being eaten in the river on Friday. So we have 3,618 veggies being eaten by all the hippos, minus those 2 hippos that are gone from the river, which would be 108 veggies that they're eating elsewhere. So now only 3,510 veggies are being eaten in the river on a Friday. We've broken this down into 3 steps. We've taken our time thinking steps, and it seems like we've come to a good answer. That's the kind of slower, more intentional, thoughtful thinking we need to do as 4th graders when we come across these math stories or word problems. We need to slow down because we get so excited and used to doing math, and we get fluent at it, and that's one of our goals, to be fluent in math. When it comes to word problems, it's more like a comprehension question, and it's like a small story with one comprehension question being asked by us that just happens to involve math that we need to use. So please understand what you're doing. Try your best skimming over the question when you're done and the story when you're done, and always make sure what they've asked you to do is adding up to what you actually did math-wise. All right, I hope you've enjoyed this lesson. Have a great day.